Hi friends, welcome to the interview preparation session. I'm Sheila. Today we are going to talk about logistic regression related to that concept. Let's understand what all possible interview questions we might face. So this is a very basic, the model in binary class. Um, let's go with basics. Let's understand the basic definition of logistic regression. Before that, let me share my screen with you. All right, let me quickly open a Word doc. Okay. I hope my voice is audible to everyone. I'm just trying to share the Word doc. I hope it's visible. All right. So going by the definition of the logistic regression, so it is logistic regression is used to predict the class or an individual based on one class or multiple predictor with one predictor or multiple predictors. So it is used to model a binary outcome that is a variable which can have only two possible values, 0 or 1. We can also call it as yes or no, diseased or non-diseased, like that. Yes, if you face an interview related to logistic regression, there's a short question that uh, what is logistic regression, and is it applicable to only binary class, or it is suitable for multi-class modeling as well? So let me write it down. What is logistic regression? All right. I hope it is visible. So to point out, this is primarily used to predict the binary class or variable. The model outcome would be 0 or 1, or yes or no, or diseased or non-diseased. Okay. So the question is this logistic regression? Because the term regression, we probably may get confused whether it is a classification or it is a regression. So friends, let us not get confused with this term. It is primarily a classification modeling. It's primarily a classification machine learning model. Modeling, which supports binary or multi-class. Okay, so with multi-class, I am trying to say that you could have more than two classes. It could be like in a sort of order, or it could be, low, medium, high. So in that case, we'll dig into deeper how it works. So it works like one versus many. Okay, we'll come to that later in a later stage. For now, let's understand that logistic regression is applicable for binary class modeling and also for multi-class in the form of one versus many. Okay. Next, how do we actually specify that it is binary and it is supposed to be for the categorical data only, right? Or let me mention this, it is specific for categorical data. Okay, so it uses generalized linear model. We call it as GLM, generalized linear model, in short GLM, which is an extension of linear regression model. It is also called as binary logistic regression, binomial logistic regression, or logit model. Also called as binary logistic regression, binomial logistic regression, or logic model. All right, we'll come to the term logit. Okay, what exactly we mean by this? Let's come to that next. So when we understand a logistic regression, it not necessarily return directly the class of the observations. Okay, it will understand the probabilities of the class. Like to estimate the probability, it uses certain threshold values. For example, logistics does not return a class of observation. It does not return class of the observations, but it estimates the probabilities of the class. Okay, this is how it is. It estimates the probability of the class membership. This is the next one, and how the probabilities are estimated. So when we see the linear model, we in any simple linear regression or multilinear regression, the values range from minus infinity to plus infinity. But in logistic regression, we see the probabilities range from 0 to 1. These range between 0 and 1. All right. So how do we identify what exactly is the probability between 0 and 1? Let's understand that. While performing the modeling, we first set up a threshold value. For example, the threshold value, fix a threshold value such as p equals to 0.5, Generally, in many cases, we notice that generally 0.5 is what threshold value is considered, but it all depends on the business criteria and the analysis of the data set. Zero point 0.5 may not be the standard one, but it depends on the business and the requirement and the business problem. All right. And next. Let's understand few other questions, the possible questions we might come across. Right. The next question is, yeah. So another question that we may come across is logistic regression a supervised machine learning algorithm? Is it a supervised machine learning algorithm? Can we say yes? Yes. Is logistic regression a supervised machine learning algorithm? Answer is yes, because we have the target variable, which is a categorical variable, which is in categorical type. All right. So if we want to call a machine learning model, machine learning method to be supervised machine learning, then we need to have an output value which is a categorical variable in logistic regression. Okay. Okay. Next. Is logistic regression mainly used for regression? Uh, See, by the term, as I said, the regression means it is probably a linear regression. But no, this is a classification algorithm. So, we just keep on writing without numbering it. It's okay. Is it a logistic regression? Mainly used for regression. No, it is a classification algorithm. All right. So let us not confuse, because the regression we often get confused whether it is linear model or a non-linear. The main thing that we understand here is we develop a different kind of models in this for each binary class. Okay. So what is the next question is what we can understand best fit the data in logistic regression. What kind of methods do we use to identify the best fit data in the logistic regression? Like, for example, what kind of methods we use to estimate the likelihood? Methods do use to estimate the likelihood. Input logistic regression, right? We use maximum likelihood estimate. We don't, in linear regression, we understand that we use least square error, MSE, RMSE, right? And in various other, we have different distance methods, Jacquard's distance and others. But here we use maximum likelihood. Okay. Maximum likelihood method. Likelihood method. Next, before we come to the next point, let us understand what are the steps involved in approaching or building a machine learning model related to logistic regression. Okay, let us remember that our output variable is a binary class. And how do we go about doing the first few steps? For example, let us go about in R and Python how we, what all packages used. Okay, let me quickly take a table. Libraries used. Okay, let's, we may all have already seen or tried applying these packages and libraries in our everyday understanding on Python and R during the assignments and projects. Let's review that once again. Okay. Can you think of any possible libraries and which you have come across and applied it? Anyone? Anyone who can answer this? Packages and libraries that are applicable for logistic regression in R and Python. Yes. So first let's look at the Python packages. Right, we all know that we use NumPy, pandas. Pandas are nothing but panel data. We have NumPy, we have sklearn, or first we'll go with the order. We will use pandas, NumPys. We have matplotlib, plot, right? Then which ones? Then we have stats models, stats model dot API, right? Stat model dot API, formula dot API, I mean, sorry, dot API, right? Then we need sklearn. Sklearn is one of the most popular packages available for us. It is a very vast package and gives us a lot of possibilities to work on the different types of machine learning models. And in sklearn we have metrics, right? Metrics, we have ROC curve, ROC underscore curve, we have AUC, we have AUC score, we have classification report, etc. All right. These are some things we use typically in our in Python while working on logistic regression model. As we go about performing our first set of business model, like a business the data pre-processing, we perform many of these data visualization first to understand the data and the patterns. We try to do a normality test, and in the highlighting thing with the logistic regression is because the output variable is categorical, we do not perform any normal distribution test, or that because our class variable is having only 0 and 1, so we don't perform that. We assume that it is normally distributed, so that test is ruled out, and we perform box plot for the input variables. Input variables could be numeric or non-numeric, so we have to perform those basic data pre-processing steps, and we check for any NA values, right? So all these are steps. We will come to those points in the later stage during the sessions. For now, we'll work on this R packages, what we have available for logistic regression. What all possible packages we need is we use GLM for model and prediction, right? And we use family as binomial. Yes. One thing I need to mention here is what is the first difference that we mention between a linear and a logistic regression is the family, which should be identified well before. Say we mention that as family equals to binomial, right? So we have to mention that. And coming to the different packages, we need HMIS, that is H miscellaneous. Whatever we have, like radar, read Excel, radar, read Excel, and then these we have H miscellaneous, right? And we have GG Ali for data visualization, right? Then for the regression model, we use GLM, right? And I hope my voice is audible, guys. Please confirm once. Am I audible? Yes, GLM net. Yes. Yes, good. GLM net and what else? What other things that you can think of? Yes, confusion matrix, right? Confusion matrix we need in Python. We have to import it from sklearn matrix. Let me write it down here. One of the most important package we need, the function confusion underscore matrix. It's also AUC underscore score. We'll come to each of these terminologies as we go forward, right? We'll dig deeper into this. We need caret for data visualization, and we have in R we use caret for our confusion matrix, and we also use information value in order to use a optimal cutoff, right? Use information value. This information value. This is typically used for understanding that what is the threshold that we discussed here, right? Fix a threshold value that can be done using this information value. And then what are the things you can think of? Anyone? Yes. Anyone? AV plot, yeah, yes, of course. Logit, yes. Good. Good. And what else? Let's come to that further. We'll keep updating this table as we move forward. Let's come to the next question. Will be the next possible question. We will also look at the AIC, right? One of the best methods to identify or analyze the performance of logistic regression is AIC, which is similar to what we have in R squared in linear regression, right? So what do we understand by AIC? What is AIC? Archaic information criteria, right? It is nothing but archaic information criteria, which is typically used to identify the required feature that we have included in the model. Is it significant or not? Meaning, is it helping the model to improve the accuracy or not? Right? So whenever we see a very high AIC against a model, that means the model is not a good predictor. Right? We have to find out that as well. understanding the value of AIC to identify the performance of the model. This is very important. Okay. Then how do we identify that? Lower the AIC, better the model. Better the model. So there is no specific scale as to what it should be. There is no standardized scale like it should vary between 0 and 1 or anything like that. But we should always consider AIC to be less and whenever we try to add or delete feature. So that helps us to understand. Okay, that is one thing. AIC is an important factor. We prefer the model with minimal AIC. Okay. So one more question is standardization of feature is required before the training a logistic regression? Yes. Do we need to standardize? Is it mandatory for us to standardize all the features before the training the logistic regression? Yes. Is it required for us to perform the standardization during this logistic regression? So the idea with the standardization is to help convergence of the technique used for optimization, right? So the idea with understanding standardization, we try to standardize so that all the features that are involved in the modeling have maintain a common scale and such that they are converged to a scale and can be further used for optimization. So in this case, because we have a binary class, we do not fully agree on this to do the standardization. Because the whole idea is to classify the target variable. So yes, if unit and magnitude are different, need to do. I do not think that is the right answer, but yes, I appreciate your attempt. Basically, we do the standardization because our output variable is continuous. And we need to find the exact value using optimization parameters like hyperparameters. In our case, the binary class, we are primarily trying to find the probabilities of our class output variable, right? So answer is no. Next question. Okay, I'm sure many of us have heard about the variable selection, right? Which of the possible method we follow in order to do the variable selection? Anyone? What is the best way of identifying method for variable selection? Anyone? Yes. We'll call it as best, but yeah, what is the method that we follow? Information gain, yes, by 1 plus, okay, e by e raised to y 1 plus, yes, this is a logit function that we will be using. Uh, we won't use this to select the feature. Okay. Information gain, we will come to that in decision tree. Okay, I'll tell you what I'm trying to say. Here, there are ways in order to identify what's the best feature, whether to add the feature or not, right? So variable selection is one of the important steps in our uh, model selection, model building and selection. So we use lasso. Lasso is one of the important method where we try to penalize the variable. Okay. So whenever we apply lasso, that is L1, right? We apply that and the variable coefficient of variable becomes 0. That's how some variables which are not adding much value, any significance to the variable, um, that that is done using lasso. Okay. We have heard about ridge also, but ridge is not used for variable selection, but lasso is used for variable selection. Variable selection. Answer is lasso. We penalize the coefficients of the variable and it may and some of the variables may become 0. 0. All right, that is the idea. We do not use ridge here because ridge is typically used in overfitting. Okay, to handle the overfitting case, we use ridge, and lasso is used in variable selection. Okay, right. Next. So one of the simple questions you may come across is what is the probability in the range, what is the range of the probabilities seen in logistic regression? We know that when we do a normal distribution curve and see that the range is between minus infinity to plus infinity, right? Probabilities in logistic regression lie between 0 and 1. Further classified based on the threshold. Then else do we understand? Some terms that we need to focus on in logistic regression is so there are some parameters that we will be using in fine-tuning a model during logistic regression. I'll just highlight those parameters for our understanding. Okay, we missed one more thing in our table. This is train and test, right? Data preprocessing, their model selection, sklearn dot model selection underscore selection. We use train and test, train underscore test underscore split, right? Yes, this is what we use. Next, let's understand some terminologies. How do we calculate the accuracy? This is a very important topic, how to understand and how to calculate the accuracy in logistic regression. Because our data, our output variable does not produce continuous data, it is classified into 0 or 1, right? So can you list out some important features, what all possible, like metrics that we use in preparing the accuracy and score in logistic regression? Whatever you think of. Anyone? Yes. Anyone? What are possible terms that we use in measuring the accuracy of the output predicted class? So to list out some, we first install. We first import the library sklearn dot model selection, and as we discussed here, we have to use metrics sklearn.metrics to have ROC curve, that is receivers operating characteristics curve, AUC area under the curve, and classification report, and confusion metrics, right? Okay. Before we come to this, there are 4 things that we have to remember. What is confusion metrics, right? Okay. It is basically a summary. Confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions are summarized with count values and broken down by each class. Okay. For example, it gives us insight on not only in the errors being made by the classifier, but more importantly, the type of errors that are being made. That will include, the true positive uh, true negative, false positive and false negative, right? Yes, you are all correct. Confusion matrix, yes, very good. Accuracy score, confusion matrix, yes, TP plus TN by TP, yes, good, right. Let me put it up here. Insert a table for the convenience. Right. Here we have class 1 predicted. Next, we have class 1. Next, first, we'll always remember the columns are in predicted results and rows are actual values. Okay, let me write it down just for understanding. This is actual, columns are predicted values. Okay, so we have this first class which is predicted as true positive. Okay, the diagonal one which is true negative. Okay, we have to remember this is called confusion matrix. By the name it is confusing, but once you get the concept, it gets very easy to understand and formulate results in it. Okay. False positive, false negative. Okay. True positive, negative. All right. Right. So when we say positive, we call it as P, right? Which is observation is positive. Positive. Okay. Negative, observation is negative. So you can call, because we are giving a threshold value, right? We give a threshold value 0 and 1. Between that, we probably give a 0.5 as our value. So anything above 0.5, we treat it as positive. Anything below 0.5, it will be taken as negative value. So that is how the machine will understand our classification, how we want to see the results. Okay. What is true positive? Observation is positive and is predicted positive. Okay, so for observation is positive is predicted as positive, which is good, right? This is an important thing for us. Predicted as positive, sorry. Okay. Here observation is positive. Sorry, observation false negative, right? True negative is observation is positive. Observation is negative and predicted as to be negative. This is what an ideal result should look like, right? When there is a positive result, it should be predicted as positive. And when there is a negative result, it should be predicted as negative. That is what our idea, achieving the goal is, okay? But many a times our machine learning model doesn't pick up the right, does not predict it rightly. So sometimes what it will do is it will create false positive into observation is positive, but it is predicted as negative. False positive. Observation is negative, but it is predicted as positive. Okay, am I making sense to all of you? Yes, is it too confusing? Yes, guys. So whenever we see a true positive case, we have this true positive, right? That means the observation is positive and it is predicted as positive, which is a good thing about the model, right? True negative, when the observation is negative and it is, our model has predicted it as true negative. Actually, this should be a negative, right? This should be true negative. False positive, when the observation is negative but it is predicted as positive. That is a problem with our model. False negative, that means the observation was positive but our machine learning model has predicted it as negative. Okay, I hope I'm making sense. Let me put it up here with the terms, short forms, TL. Is it clear? Right? Is it clear? So this is how we identify, and further how do we calculate the accuracy? How do we calculate the accuracy? That is nothing but true positive plus true negative by true positive, true negative, false positive and false negative. So we have to put it as accuracy equals to dp plus t and divide by, put it like this, n, right? Very important formula that we have to remember. Okay. So further we will understand how the misclassification rate can be identified using the various curves we have, right? True positive rate and true negative rate. We must have come across this true positive rate. So true positive rate is also called as recall. Okay, it is also called as recall, rec. In this, we will calculate the number of correct positive predictions divided by the total number of positives. Okay, true positive rate. Also called as rec. And this is calculated as sensitivity. We call it as sensitivity. By plus P. This we write it in words so that you can understand. Number of correct predictions divided by total number of positives. Okay. So we ideally look at it as a sensitivity idea value should be 1. Best value. Best value is 1 and worst value is 0. This we would never want to have in our calculation. Right? Next, we have true negative, which is called specificity. What is specificity? Before that, let me write down the formula for this. True positive rate all right. Then true negative rate. Let's discuss. I think we have reached the time now. Looks like we'll have to continue the session tomorrow also, right? Seems like we have crossed the time. So let's do one thing, guys. Let's continue this session for tomorrow also. Okay. For today, I think we need to wrap up, and let's continue the same session, same topic tomorrow as well. All right, guys. Thanks for watching. See you tomorrow.